that we want to solve together. We have a lot of questions to solve together in this place. This is Chemical Kinetics HM47 problems and solutions on past questions. And I'm starting with what we call activation energy. Thank you. So make sure you subscribe on my YouTube channel to always watch more video whenever they are available. And I also love to keep posting more videos concerning this. Okay, let's go together. Now, the problem we have to solve in this place right now, it has to do with what we call the activation energy. So a rate constant of chemical reaction is 1.78 times 10 raised to the power minus 4. So from these questions, we have the givens, which include, without wasting much time on that, we are given the rate constant 1 is given to be 1.78 times 10 raised to the power minus 4. And the temperature at which it occurs, temperature 1, is 40 plus 273. Take note of that there. And then we're going to have 3, we're going to have 3 Kelvin. And also, and 1.K2 equals to 1.38 times 10 raised to the power minus 3. And at what temperature T2 equals to 80 degrees Celsius plus 273, and that will give you 3. Then you're going to have a 5. You are going to have 3 Kelvin. Now, the question now says evaluate the activation for the reaction. So the question asks you to calculate the activation for this reaction that you have right now. So in order to solve this problem, quick one, this is what you need to do. You need to apply the usual formula we normally use to solve this given problem. And the formula that is applicable for solving this problem is where we have the ln of K2 over K1, okay, equals to our EA over R into brackets. Then we have our T2 minus our T1 over our T1 times our T2. That is what we need there right now. So applying this formula, then we compute those data that we have there. So from what we have in this place, the given parameters, then we're going to have the ln of K2, which is 1.38 times 10 raised to the power minus 3 divided by our K1, which is 1.78 times 10 raised to the power minus 4, then equals to our EA. Our EA is what we are looking for, our rate 8.314. Then we are going to have our T2 from the question is given to be 353 minus our T1 from the question is given to be 313. Okay. Now, from what we have there, our T1 and T2, multiplying them together, 313 times 353. That is what we have there. Now, if you look at this arrangement, the arrangement fits in for exactly what you want to solve here right now. So, let's quickly solve the upper one and the lower one together in order to get exactly what we need there right now. So, for the two of them that we have there, you did the arithmetic of these two together, and then we are going to have the ln of the parameters of this one here can be written in ordinary form, so it suits it. Or you have 1.38 over 1.78 times 10 raised to the power minus 3 plus 4 close bracket equals to EA over 8.314. Then when you subtract this from this, there you are going to have 0. Here we are going to have 4, and here we are going to have nothing, all divided by. When you multiply the lower one, what are you going to have there? 313 times 353 will give you some total of 110489. Okay, so here, bring what you have in this place to what you have here. That means we're going to have after solving everything here, ln into bracket, we are going to have 7.7528. That is what everything here will give you. Then into bracket, we are going to have EA over 8.314. Then we are going to have, now when you solve what you have in this place, 40 divided by this value, eventually it's going to give you 0.00006, 361. Okay, now from here, do the link of this value that you have in this place. If you cross multiply, you still have to have link 7.7528, then multiply by 8.314 equals to EA, followed by this multiplying this to give you 0.000361. Now, here we go. The length of 7.77528 will give you 2.0481 times 8.314 equals to EA. Okay. Then 0.000361. This will eventually give you 17.0275 equals to EA divided by 0.000361. And eventually we are going to have EA equals to 47167.64. Now, activation energy, that is expected to be in form called joule per mole. Now, if you convert it to kilojoule, then what are you going to have there divided by 1000? So, when you divide it by 1000, that will give you 47.167 kilojoule per mole. That is how to solve the question, and that is what the question asks you to calculate over there. Now, I want to believe that is clear to you right now. Very good. Now, another problem I would like to solve in this case, in connection to these past questions and how problems are being solved concerning them, including those related to the order of a given chemical reaction. Yes, the order of a given chemical reaction. So, in connection to that, let us quickly look into this carefully. Let's look into this carefully. There is another question just like this particular one that we have on the board right now. So, I want to give you this one as an exercise so you can do it from your end over there. You can solve the problem by yourself. So, I want to give you the parameters to solve this related problem. Get the parameters, just solve the problem by yourself and derive your final answer concerning that. So, a self-assessment question for you to do right now. So, when you are given your K2 to be 0.000693 and your K1 is given to be 0.000139, then you need to look for the activation energy when the rates remain 8.314 and you are given the temperature 2 is given to be 310 and temperature 1 is given to be 300. Remain Kelvin and Kelvin. Take note of that. So the two of them also share the same unit, which is liter per mole per second. So what is your final answer? What is your final answer? Let me know that in the comment section when you are through with that. Let me know that in the comment section. Now, in this place, there's another problem I'd like us to solve here together. And the problem is on second order Consider the following reaction you are given. So what reaction is that are you given? Definitely, you are given this reaction here, that 2 mg plus O2 to give rise to 2 mg O. It now says the rate, if the rate equation can be written as rate equals to Kn mg x then O2y. Then you are provided with the result of some of the 3 trials below, and those results you are provided with, including the following. We have experiment number. We have experiments number 1, number 2, and number 3. Okay, and you are given the inertia, that is inertia mole liter of mg. Inertia, you are given the inertia of this to be 0.8, or we have 0.20, we have 0.10. We are given the inertia of O2, inertia of O2 to be 0.10, 0.10, 0.20. Now, we're given measured rates. In this case, we have 0.02, excuse me, 2, we have 0.004, and we have 0.008. Now, this is a particular analysis given from a problem solving right now. And so what do we have to do here right now? Now, there are questions you need to answer on this carefully. What are the questions you need to answer carefully? You have to calculate what is the rate law for the reaction. You need to find the rate law for the reaction. That's number 1 there. Now, number 2 is that what is the overall order of the reaction? Take note of that there. And number 3, calculate the value of the rate constant. The value of rate constant, which is the K. Take note of that. Now, let's go into this carefully. So we are going to be using the parameter for each to solve the problem. Parameter for magnesium, parameter for oxygen, and the rate measured. The measured rate, which is also in mole per liter seconds. Take note, everything is mole per liter seconds. Take note of that. Very good. Now, let's start with the first question asks us to calculate concerning this. The first question we'll solve right now is that the rate law for the reaction. Number 1, the rate law for the reaction. So the rate law for the reaction right now, in accordance to what you have there, which is with respect to this, what is value of Kn, X, and Y? We have to find out carefully. So with magnesium, for magnesium, which is Mg, now in this case, this and this are constants. So we can make use of these two to solve the related problem, which is on different experiments that we have there. So we can have this being used together there. So we are going to be using experiments for magnesium using experiments 1 and 2. Yes, using experiments 1 and 2. What do we have there? So this is what we have in that place. When we use experiments 1 and 2 for A, that means we are going to have 0.20 over 0.10. That's how we put it. Then equals to, for the experiment 1 and 2, we have 0.004 over 0.002. This will go in this to give you 2. Take note of that. Equals to. This will also go in this. Remember, this will go in this. That is 2 times. Okay. So this will also go in this as well. Then we are going to have 1 here. Take note of that. This the 0.0, 0.10 will go in this, and 0.02 will also go in this one here. So from what we have there, this code, then we have this one there. So eventually, that means that so therefore, the order of mg equals to what? The order of mg equals to 1. So for O2 using experiments, now for O2, we are using experiment 2 and 3 because experiment 1 and 2 are constant. So experiment 2 and 3. 2 and 3. So what is the value of experiment 3? 0.20, 0.10. Then equals to, there we are going to have 0.08 over 0.004. That is what we have there. Now, since you've gotten these two that you needed there right now, so what you have to do next is just compute factors and put them in order. Now, from the first one that you have there, what are we going to get from A at the end? I was considering using experiment 1 and 3 rather than the experiment 2 and 3 in this place right now due to some certain reasons, because 4 will go in 8, that is just 2 times. Well, that will not give us exactly the clue we need for the experiment, so it will be much more considerable when you make use of 1 exactly when you make use of 1 and 3 rather than 2 and 3. So excuse me for that. Now, because of the large difference in those values, they take note of that. So this one will be 0.002. Now, from what we have, this will still give you 2, while this one will give you 2 raised to power 2. You will definitely know that because this can go here to give you what? 4. So if that is 4, 2 raised to power 2 will still give you what? 4. Okay? If you look at this one here, 2 will go in this one to give you what? 2. So 2 raised to power 1 will still give you what? 2. That's it. Now, in this place, we are going to say that the order of O2 equals to 2. So if the order of O2 equals to 2, that means let this one be our x, let this one be our y. So therefore x equals to 1, then y equals to what? Equals to 2. So we now want to give the rate order for this. 1 plus 2 we give you 3. This is thermolecular. That is what we have there, thermolecular. And if you now want to write the rate law for this one right now, so what we have to do is we need to calculate what we call the Kn. But they said the rate law for the reaction is what? So the rate law for the reaction is everything. The total order is 3, which is what? Thermolecular in nature. So then we need to calculate for the second one. The question asks you to calculate from there. So what does the question ask you to calculate, which is the second one there? Right now, we proceed. We proceed on that. There we are going to be using the given parameters that is available. Is very, very important. We have to use those parameters that is available. Now here we go concerning that. Since we've gotten x and y, we can just write this in form of what we call the, where we are going to have rates Kn, where our Mg equals to 1, this is 1, and our O2 equals to 2 there. We've already procured that. Then we need to calculate what we call the Kn. Yes, in order to solve for the Kn, which is question number 3, from there, this is what we have. Then we are going to be looking for what we call rate constant. Rate constant. The rate constant from the parameters that we have there, where we have the two of them, the same. So we will bring it out there. Our R equals to 0.02. Stick to that. Then our Kn is what? Is unknown, which is exactly what we need here right now, which represents our rate constant. Then we are going to have our mg in that place to be 0.01. Then we are going to have our O2 to be 0.01. So where we have everything there constant, 0.10, 0.10, this one is 0.002. Yes, 0.002. That's what we're actually using there. Now, compute all of them as expected of you. What do you have? We're going to have the expression rate equals to Kn that we're actually looking for. Then our mg in this place, we are going to have 0.01. Now, what is the order? The order is just 1 into brackets. Our O2 is also 0.01. What is the order of O2? That is what? 2. Now, our rate is this one here, 0.002 equals to Kn that we're looking for. Again, we are going to have 0.001. This one here, we are going to have the value 0.01. And that's okay. So have here Kn, multiply all these together. What are you going to have? That will give you 1 times 10 raised to the power minus 7. So you are dividing both sides. Kn now equals to 0.002 divided by 1 times 10 raised to the power minus 7. And that also means 2 times 10 raised to the power minus 3 over 1 times 10 raised to the power minus 7. So which will now eventually give you the value that we have here. We are going to have 2000 at the end. So for that 2000 that you have there at the end, when you check it out, our Kn now is 2000. If our Kn is 2000, then you can now work it this way, you write. So therefore, we are going to have rate equals to 2000 into bracket mg, then into bracket O2 raised to power 2. That is it. That is exactly what we have there. That is what we need to do. So next class, we shall continue on this and we shall discuss more concerning the past related problem.